Welcome everyone, and thank you for joining our webinar with CALIBRE Systems discussing Neo4j for total cost visibility for the U.S. Army. My name is Meryl Lee, and I am part of the webinar team here at Neo4j, and I will be your host for today's event. We're so excited to have you here with us. So a couple of housekeeping items before we get started. We invite you to submit questions throughout the presentation using the Q&A tab located at the top of your screen. We'll hold off on Q&A until the end of the presentation, but please go ahead and submit your questions throughout, and we'll answer as many as we can during our time frame. The webinar is being recorded, and the on-demand version will be made available within 48 hours. With that, I'll go ahead and hand it over to Jason Zagalsky, Federal Account Manager at Neo4j. Jason?
Hi, my name is Jason Zagalsky, and I manage the federal government and system integrator business for Neo4j. This is our first Graphs in Government webinar, and there is a white paper with the same name, Graphs in Government. You can find it at neo4j.com, and I invite you to download it to learn more about graph databases with several government use cases, including the U.S. Army use case that you will hear about shortly. For those of you that are not familiar with Neo4j and graph databases, I will kick this webinar off with a brief overview of Neo4j, the company and the product, before passing control to Preston Hendrickson to tell you how CALIBRE Systems is using Neo4j to help the U.S. Army achieve total cost visibility. Neo4j is the market leader in a fairly new database category which we created, Graph Database. Nearly 20 years ago, the founders of Neo4j invented the Graph Database with the labeled property graph model when they had a problem that was difficult to solve with relational database technology. About 12 years ago, Neo4j was founded to create the world's first open source graph database. With the free open source Neo4j Community Edition, we created a massive community around Neo4j. You can see the evidence of that under the ecosystem on this slide. We then created and released the commercial Neo4j Enterprise Edition product, which has become extremely popular and led to a large graph database market into which several competitors, small and large, have emerged. However, none of which have been able to put even a small dent in our market leadership position. I will explain what the secret sauce is in Neo4j and why others can't compete. Before we move off this slide, however, let me run through some of it. When I joined Neo4j about 3 years ago, we were about 125 employees, and today we are about 330 strong, and kicking the growth into even higher gear as we move into 2020. We have seen more than 30 million downloads of Neo4j, and we have over 400 customers of Neo4j Enterprise Edition. We are well funded with venture capital with 160 million in funding to date, with the last round of 80 million coming in November of 2018. In the second column, you can see our strong adoption in major commercial verticals, and then some sample commercial customers in the next column. And in the federal market, Lockheed Martin is one of our large customers. DHS is a customer, and we have customers throughout the Department of Defense, including Army, Air Force, and Navy, and some small DoD agencies as well. We are in most of the big 6 intelligence agencies, and in the federal civilian sector, NASA is a big user of Neo4j, among other early adopters in that sector. In the partners column, just a few of our partners are highlighted. Of course, we have our partner CALIBRE, along with GraphAware, who are services delivery partners, Linkurious, a graph data visualization partner, and the 3 major cloud providers who we also partner closely with. As I already mentioned, Neo4j invented the labeled property graph model. It consists of nodes, relationships, and properties. The circles on this diagram represent nodes which can have labels, such as person and car. The arrows represent relationships which have a type, such as lives with, or drives. Note that relationships also have a direction. Both nodes and relationships can have properties, which are stored as name-value pairs. So if we look at the small graph here, you can easily and quickly see that there's a person named Dan who is married to and lives with a person named Ann. They each have a born property that is their birth date. Dan has a Twitter handle property, Ann does not, and that's okay. Ann owns a car that is a Volvo V70, but Dan has been driving it since 2011. So with just a quick look, you can see that Dan is a bit of a freeloader, living with Ann and driving her car. But I guess that's okay, since as we can see, they are married. Okay, so now that you understand the labeled property graph model, what is Neo4j? Well, put simply, it is an enterprise-grade native graph database. I will get to what we mean by enterprise-grade and native shortly. Neo4j allows you to store and query data relationships. It is a database that is all about the relationships. You can query any levels of depth in the graph in real time. I will get to why and how. And you can add and connect new data on the fly. It is schemaless. You can create new nodes, relationships, and property types at any time, and then just add the data without having to reload your entire database. Neo4j is a native graph database, designed and built for graphs from the ground up, providing all of the benefits you see at the bottom of this slide. Neo4j is not just the graph database, but Neo4j is a complete graph platform. Neo4j provides all of the pieces around the graph database to make it easy to build a solution around Neo4j. Starting on the left and going clockwise, we have tools for development and administration, drivers and APIs, discovery and visualization tools, analytics tooling for graph analytics, and data orchestration tools at the bottom. We provide everything you need around the database, the complete graph platform, to make it easy for our customers to build a connected data solution on top of the Neo4j graph database. Now, why might you want to use a graph database? Well, graphs are everywhere. Anytime you have connected data and want to get insight into those connections in your data, you probably have a good graph use case. In this slide, we show 3 different categories of graph use cases. We have AI and graph analytics use cases for data scientists, graph visualization use cases for business users and analysts, and then on top, we have transactional graphs that process large volumes of data and feed applications. But don't get hung up on only looking at these sample use cases that are well known for graphs, because graphs really are everywhere. And more than half of our customers have use cases that don't fall into any of these well-known use cases. Finally, I want to share with you what is the secret sauce in Neo4j. First, most vendors out there trying to get into the graph database market are simply providing a graph layer on top of a relational or NoSQL database. Neo4j is a native graph database. The nodes and relationships are stored natively as nodes and relationships, in memory and on disk. There is no underlying data store. Neo4j is the database. Now, along with the native graph architecture, we have a concept we call index-free adjacency. Neo4j connects the data at write time as it is stored. So every node knows every other node it is directly connected to and how. This allows for lightning-fast traversal of the graph, providing a real-time response with even the most complex and deep graph queries. Contrast that with relational databases, where every hop of the graph during a traversal requires a join table and an index lookup. This chart shows response time on the y-axis and connectedness and size of data set on the x-axis. As you can see, the response time for Neo4j, the blue line, is nearly flat, even for the most complex queries going out tens or even hundreds of hops and the largest data sets. Now look at the gray curve for relational and other NoSQL databases. Once you get beyond 2 hops and as the data set grows, the response time goes up exponentially. Neo4j's native graph architecture and index-free adjacency thus often provide a 1,000 times advantage or more, bringing your response time from minutes to milliseconds, even with your most complex queries on very large data sets. Why does that matter? Well, in cases where you really need a real-time response for your end users, you can have it. Real-time response that you could not achieve with any other solution. And in cases where you're doing batch analytics, you might be able to update your analytics several times a day or daily instead of every few days or weekly. And now I will pass it over to Preston to talk to you about achieving total cost visibility for the US Army using Neo4j. Preston?
Hello, everybody. Thanks, Jason, for the introduction. Everybody, my name is Preston Hendrickson. I work for CALIBRE as a systems analyst for about 24 years now. So I will introduce to you a use case that our particular customer for the Army. So let's get right into it. So this is our requirement from the customer. So we have built this system to answer these types of questions, everything from planning to programming down to support costs. We're primarily concerned with support costs, support and maintenance, but we do get randomly, periodically questions about, for example, cost-benefit analysis. So we'll provide historical data information. We also do, at the wider scope, business case analysis. Does it make sense to do something? We also help with those kinds of analysis. In the form of, we provide either cost factors or historical data, costs, maintenance costs, and we're going to go through most likely 6 of the type areas that we like to call our great circle of life. So let's do that. Let me explain the great circle of life. So this is what I personally have nomenclature, great circle of life. So we go from weapons definitions to force structure to inventory, requisitions, maintenance, and ammunition. So total cost visibility to us is each one of these areas have cost and cost drivers that help, I guess, build how we spend or how we track costs from operations and maintenance perspective. Some things you're not going to see in here, for example, in force structure, you're not going to see personnel costs. That is tracked separately. Military pay is a little different. As well as in maintenance, we do show contractor and civilian costs in terms of government civilians and military costs for maintenance specifically. So we'll tackle the first one. So weapons definition, one of our primary products is a weapons definition and a price explosion. So here we have a tank, and each part of that tank is labeled. Well, if we strip that tank out and break into individual parts on the right, we can put costs not only for not the acquisition cost. I mean, you can't take the cost of all the parts and add them up together and say that's the cost of a tank. It's more so the cost to maintain the tank. This is the portion that happens after acquisitions does their part. So each particular part and each thing that goes down from the panel down to the ball bearings, down to the nuts and bolts can be represented in the graph. What that looks like, so here we have an example of what that looks like in the graph. This is a real snapshot from real data. So on the right-hand side, I will describe this little engine part to show you what the part on the left represents. So on the very far right, you see there's like a 19A, a small casing here. So you have nut 20 that fits on wing washer 12. But on the far left, you also see that same wing washer 12 also fits nut 11. So on the left-hand side, what we have is that light blue is our lens light. The medium blue, which is a slightly same size circle, or nodes in this particular case, are our components. And then the dark blues, the slightly bigger nodes, are going to weapon systems. So what we have is a bottom-up approach. This is a picture of what systems and components does that lens light fit on? And immediately you can see some patterns. And Neo4j is basically, as Jason recommended and stated, that relationships are key. So if I see on the very top far right where we have a cluster of weapon systems that share commonality between 4 components, on the far left is the same pattern. I see 4 components shared by another small cluster of weapon systems, then I can immediately say, if I'm on the shop manager floor from a business perspective, I want to make sure I have those parts in stock because they are going to be critical to readiness of those weapon systems, not to mention they can be interchangeable parts. And I want to make sure not only do they just fit on, but they do that over time. So we do track a parts explosion for each weapon system from bottom up, and we do a top-down representation. That also includes the cost for that particular part, how it fits on relationships, and how many they fit on. For example, a particular lens light may fit 4 times on a Humvee, or it may fit 8 or 10 times on a Striker. So we do track those in terms of quantity, relationships, interchangeable parts. As an explosion, this is one of our deliverables. So this is a parts explosion look of how do we do a bottom-up look on how do we track each part that builds a system. It could be a tank, it could be something as small as a desk. So we also track the material catalog for the Army, which is 1.8 million parts. We track that per month. Moving to the next portion of our circle is force structure. This is a typical example of how the Army is structured, from field Army down to a squad. And as you go up or down this sliding scale, we have an example here of a Striker team. And if you look on the left, so brigades have 3 to 5 battalions, battalions have 3 to 5 companies, and you can go downwards. This is one example how a Striker brigade can be set up. So we have a couple of companies, an intelligence company, we have support companies, engineering companies, and infantry battalions on the bottom. So this is nothing new. You can pull this, or you can grab particularly, this is free information off the government. You can free information off the Google. You can pretty much do a search and get this. Nothing you're going to see today is going to be proprietary. This is basically how we represent the information so that's easier to digest. Okay, so inventory has a depiction like this. So in the real world, the Army owns things. So on the bottom right, they own Striker. This is what people normally see in the real world. They see the Army owning tanks, Strikers, guns, and ammos. But what they typically don't see is that the Army also owns and maintains and operates warehouses, stock levels. They operate and maintain not just the guns, but the racks that they fit on. So the complete inventory is a lot more going on behind the scenes. So we do track that. So this is what this looks like in terms of inventory. So on the right-hand side, we have our small units, and they own things. So on the far right, the gray nodes is how a unit owns non-weapon system things. That could be the desks, it could be warehouse buildings, the racks, chairs, basically anything that the unit needs to operate. On the left-hand side is a unit that owns weapon systems. And this is a depiction of a particular brigade that owns different types of weapon systems. And they're not just tanks. It could be something as small as a gun, a pistol. It could be something as a rocket launcher. So there are different types of equipment that are deemed as weapon systems, but there are some that are not. Some can be rolling stock, some cannot be rolling stock. So just the matter of applying business rules to determine which is which. And since the Army has a catalog of over 1.8 million parts, we try to identify those using rules submitted to us. So this is the highest level look of inventory. And let's see if we can go to requisitions. Now, this is nothing fancy, but there are some pertinent things in here. So as a graph database, we can just take one line of information. This is a requisition line. And we can parse that out and break it up into different colors, and then we can relate those to each other. So this is an example of how the Army orders parts. So in the requisition line, that NSN, is the fourth portion of the light blue, that is actually a part number. So we can actually take that and we can make representations. So we go to the next slide, we can see how the Army does this ordering. So on the left-hand side, we have that little small unit, the ones in yellow, the orange, owns a weapon system. And that system has different parts that fit on it. That's the little light blue parts. Well, every time a requisition is placed, those light blue parts have orders. So for example, on the far left, you have 2 orders for the same part. Well, over time, we can track that by quarter, we can track that by year, we can do roll-ups. So that one line of accounting that says, how do we order a part, we can track it this way using one line. So each part of that line is broken out to information. The part on the right is the same depiction, except it tells me who paid for it. So that's the activity, the account itself. So an activity can support multiple orders for the same part for a different unit, or it can support multiple orders for multiple parts for many different units. It just matters how we do the depiction. In this case, we chose the simpler of the examples. So we have a unit in the far middle, so it's a little smaller now, but you see two lines coming out of it. That's because that unit owned that weapon system in two different time periods. And we can track the orders for that weapon system across time for both time periods, using relationships that are built in the requisition itself. So looking at the great circle of life, if I know the weapon system, which is the dark blue, I know the parts that fits on it, which would be the light blue, and I know the unit that owns it, which is force structure, and I know the inventory that they have, which relationships to the dark blue, then I can tell you what got ordered for it, which is requisitions, and then who paid for it. So that great circle of life was started to build upon each, basically trying to build upon itself. So I'm going to move over to maintenance. Maintenance is a little complex. I'm going to cover this a little slower because it's not intuitive. So on the top left, you see a typical depot warehouse where different things can be maintained at the same time. So for example, in one bay, you may see a tank, another bay, you may see a striker. So there are different types of parts that are needed at any given time. And on the right-hand side, it's not just about a warehouse rebuilding something. It could be something as simple as a wash rack, which is what you see depicted on the right. So in terms of maintenance, there are three things going on. It's not just the equipment, it's the maintenance that's being performed on it and the personnel that's doing it. So as I said before in the beginning, that we do track personnel in maintenance only in terms of we track the contractors, civilians, and military, and the cost it does to maintain it and how long it takes. So let's break that down. I'm gonna try to take this a little slower. On the left-hand side is a simple example. So we have our same unit in orange and owns a weapon system. The purple nodes are the maintenance requests. So now I have a maintenance request to use a part to fix a system. That is the simplest version of a maintenance request. On the right, it gets a little complicated. So we have different types of units here. In the middle, you have a unit that has red relationships. This means this is the unit that actually perform the maintenance. They're the wrench turners. They take up the casings and do the cleanings. On the outside, with the purple relationships, this unit made the request. So you have a unit that makes a request for a part to perform maintenance on a weapon system that was performed by a different unit, which is a little hard to say. Say that how you say that like 5 times. It'd be kind of tongue twisting. But on the bottom right, you see some units can do both. This particular unit made the request and they actually get the servicing for it. And that's fine, so it's quite all right. So in terms of patterns, the unit that makes the request and the unit that performs the request, we track the cost of both. And we also use the same patterns to depict issues with the data. So we purposely we moved some information to prove this point. In the situation where you have a weapon system that performs maintenance on a weapon system, normally you don't see that. You wouldn't want to say, I'm going to take a tank and put it on another tank. What normally happens is a part of a tank is put on to use maintenance of the tank. So for example, I may want to take the tank tread or take the turret off one tank and perform maintenance to replace another turret on a different tank. What we would normally want to see is not the weapon system itself. We want to see the actual part. We want to see the actual tank that got used. The tank part, for example. I want to see a light blue node that actually has the information for the thing that actually got replaced, not the whole weapon system. Not to mention, your weapon system and maintenance should be not owned by a unit. In this particular example, these two weapon systems, you do not see relationship directly to a unit. So this will be an example of a unit that is non-owned or non-accounted for. So this will be what we consider to be a bad pattern. We will identify this and send this back to the maintenance shop and try to get more clarity to figure out what happened. So we can actually use relationships to show us what is in the data. We can actually look at it and just by eyeballing it, tell us something is wrong with the data. So we can do both at the same time. Ammunition is the most complex. So we're going to talk about ammunition in 2 parts. How do we read it and how it's actually implemented. So there's a delay again. I'll make sure I don't click again. Okay, so we have here an ammunition example using a tank. So on the top left, you see bullets, and that looks pretty okay. But when people look at this, they think, okay, the tank shoots bullets. That is not true. The tank uses bullets. It does not fire the bullets. Each mechanism on the tank actually fires the bullets. This is how you read this. This Abrams tank uses ammos type 1, 2, 3, and 4. But it's the gun that fires ammo 1, the grenade launcher fires ammo 2, and the turret fires ammo 3 and 4. What that looks like on the right is I have a unit that owns this weapon system that has this firing mechanism. So in the red relationships, the weapon system uses ammos 1 and 2. The firing mechanism actually fires ammos 1 and 2, using the example on the top right, the top 2 red bullets. But on the right, you also see that the same part can fire 3 different types of ammunition, but not necessarily mounted to this weapon system. For example, this particular ammo can be used on a weapon system, but it may not be able to be stored on that tank. It may not be enough storage space. So if you take this particular apparatus, a fire mechanism like a gun per se, if it's mounted on a different weapon system, then yes, it will be able to fire. So what you want to see is a triangle. So in the top middle, a weapon system that fires ammo used by the tank, fired by this part. So this triad, which we're going to focus on the next slide. And there's 3 use cases for that triad. Make sure there you go, the delay's working with me now. We're going to take the far left and explain the 3 different ways to view the triad. So you have a unit in the middle, obviously, the little orange. So this unit expends money on this ammo. And of course, all the relationships that you see on the left side say fires. So this is an example where a unit expends money on a weapon system that fires ammo. Going to the top portion of this, you have a unit that expends ammunition for a weapon system that fires and uses the ammo. So an example of something that does both fires and uses, this is the example of a rocket launcher that actually fires and uses ammo at the same time. Directly to the right of that is the example we saw on the first slide is a tank. So this is a unit that expends ammo for a weapon system that uses the ammo. Not necessarily fires it, it just uses it. So on the left, there you have a fire, that's going to be a gun. In the middle top, that's going to be a rocket launcher that fires and uses. And on the far right, you have a tank that actually just uses. What you want to see is the triangle that you see on the right-hand side. At the bottom, you have a unit that owns a weapon system that fires or uses ammunition that they have spent money for. And in the middle of that, you see a whole bunch of lines there. If you read one of them, it says owns 2014-4. So basically, this means that this unit owned this owned this weapon system in 2014 Q4 that they expended, basically they expended money for the ammo that uses and fires on the weapon system. So that triad is what you're looking for. Anything other than that, that means that ammunition can either A, be used and not fired, or it can be fired and not used on any particular weapon system. And we do track that. We do have several reports that we give back to the Army that says, well, this unit expended ammo for a weapon system that they did not get used on. And then we can track that back and figure out what happened. Was there chain exercise? Was the wrong ammo order? We can do all kinds of things like that. That's very rare. It's extremely rare for that to happen, but we do see that, and we do track that, and we send it back for corrections, and we do make corrections and send it back out. So I think we can, this was the complete circle of life. We missed force structure. I will try to dive back into it while we go through some questions and answers, but for now, I'm going to turn it back over to Jason. I'm just going to go back to that slide. I can pick up where I left off so that there's no dead space. Jason, if you can take over, and I will go back to that slide if I can find it.
Thank you, Preston. It's actually Mara Lee who's going to come back on. I just wanted to say that was a great visualization of the graphing technology, and we are going to be taking questions now, so please go ahead and submit them in your Q&A tab. We've gotten some throughout the presentation, so I'm going to just start with one we received. It says, can you describe how you got started transitioning from your old database to Neo4j?
Absolutely. It's interesting. I walked into a meeting one morning, and then the boss says, like, hey, guys, we got to get off this thing. We got to move something else. So we went from a mainframe system to a graph database system. And the first thing we did, so Neo4j did a very good job. They handheld us for a while. They are very adamant at making the success of their customers. So as a new customer, we were already shaking our boots because we are a SQL Server, Oracle, relational database kind of shop. So they handheld us. We got trained on how to rethink and how to retrain our minds. And then we went straight to it. We started doing whiteboarding. So we drew circles and lines, and we actually went through several sessions, and they walked us through how to, not only how do we see the data differently, but how do we make that small data set into a reality. We ran queries against it, and then we started getting bigger and bigger and bigger. And then we got self-sufficient. They were able to become more of a support role than necessarily a driving role. So it was a very good experience for us.
Excellent. Okay, we have another one that came in. Let's see. Can you describe programming in Neo4j?
Absolutely. Neo4j has a vast developers kit. So we started off, I'm answering in two different parts. So there is Cypher, which is actually the, I guess, equivalent to your SQL in SQL Server or Access in Oracle. Cypher is the language for graph databases in Neo4j. So we was able to be trained on how to write Cypher, how to get data out and in. And then on top of that, of course, there's your application. So to mirror the two, there's our developers kits and there are drivers that allows us to interact with Cypher. So we have drivers for C#, there's Java, Ruby. So I mean, it's pretty much almost anything you can think of, Python. So for us, we were able to take different parts of applications. So in our case, we have C#, we have Python, we have a lot of relational databases. So we sit on top of that, and we do our direct processing. So we utilize their driver kits, and we utilize Cypher to do all of our programming so that no matter who's in the seat, they feel more comfortable in their environment.
Excellent. Let's see here. What is the user interface for the system? Is this something users interact with, or is this a report generation tool?
Great question. So we have 3 different types of users. For a customer, we literally took this and embedded it into a website. For our internal analysts, we custom built, we have websites, we have form applications, whatever that particular analyst works best at, we have created custom front ends for that role. So it is very, very flexible. You are not locked into any particular interface. You are definitely free to use a single page application if you want to. In one case, if you're free to use a Python script running in Jupyter Notebook, that works just as fine as well. So it is very adaptable to use either.
Great, thank you. There's so many questions to scroll through. I'm doing my best here. Let's see. For the case study, does Neo4j enable new forms of analysis not previously possible?
There's a case study. Great question. So Neo4j is always evolving. When we first started, we were Neo4j version 1.9, something like that. I mean, we barely had an interface. We were doing a lot of coding. But now it is amazing. So there are interfaces popping up. The technology is vastly growing. There's a newer version coming out later this year. I believe I'll let Jason talk to that. So once you're bought in or once you're clued into the graph database world, you're not stagnant. It definitely evolves, and it evolves rapidly. They do a great job on their websites tracking the chain sets, and you can see what's being planned, what's coming up next, what made the cut, what didn't make the cut. So the communication is amazing. I hope I answered your question correctly. I think the intent is you are not left holding a bag if you're jumping into this realm.
Right. No one wants to be left holding a bag, for sure. Okay, here's another question. We have time for about 1 or 2 more. Let's see here. Can you make different zones to compare the object's uses or needed from the budget? Can you graph to see how much money it costs each unit in years? I think I'm interpreting that question correctly.
Yes, I think so. The question sounds like the basis is around analysis. So yes, by requirement, just like any other database, you can do roll-ups and drill downs. So cost drives from like bottom up, take the individual costs, and you can do sums and averages and aggregates going upward and same going down. In our world, our requirements, we do have different time periods per data source. For example, we can report daily, monthly, quarterly, and yearly. Or we can do ad hoc at any given time because our processes are ran in a way that we're not locked because our database, you can dynamically refactor live in the graph. So if you have a data file that comes in monthly, you can refactor your graph in terms of time and get daily information out of it as long as that data is inside of your data feed. You can refactor very easily and quickly and get new answers out of the same data in terms of time. Hope that answers your question.
That's great. Okay, so we're going to take one last one, and then just so you know, if you've asked a question and we haven't answered it, we will follow up with you directly. We get a file with all the questions that were asked by person, so we can follow up with you and answer your question directly. So just want to let you know that. So I always like to leave with lessons learned. So let's do that. I have a question here. What were some lessons that you learned from your transition? Learnings are always good.
Oh, outstanding question. So number one, lessons learned. So when you walk into your first day of looking at Neo4j and you have Oracle SQL Server access, the relational database mind, the first lessons learned is do not underestimate the amount of time you may take trying to retrain your brain. Some people got it immediately, and some people kept trying to put the relational mind around a graph structure, and it just doesn't work. You have to really walk in, check your database knowledge at the door, start off as a new kid in the block, and you need to relearn and rethink how you work with data. The second thing is estimating time is different. Processing time is slightly different. So what used to take, I'm going to go into a real deep example. When we had a weapons definition that got down to like 8 or 9 degrees, basically 8 hops away. Well, in the SQL Server world, you have to create join and join tables. And at design time, you have to know that for every join hop, you got to do n-1 joins. In relationship world, you can create that 8-level detailed drill down of a parts explosion and run that with one query. And then your mind's like, well, how? And you start asking yourself how and why. And it's just the nature of how it's designed. So do not underestimate that you can't transfer one-for-one for a graph to a relational and back or vice versa. It is just different. You have to just retrain your brain. And that took the most amount of lessons learned topics we spent the amount of time doing.
Oh, interesting. Thanks for sharing that experience. I mean, there are some things that people don't even put into the transition phase, and just retraining your brain, I would think, would not be one that people would think of top of mind.
Okay, I lost that last section. Say the last part again.
Oh, you're good. We're all good.
My headset kind of slipped off my head for a second. I'm sorry.
Well, that was about it for our time for our Q&A. We want to thank both Jason and Preston for being with us here today. We will be sending the recording out, so check your inboxes in the next 48 hours, hopefully before that, for a link to the recording. Thanks again for joining us, and have a great day. Thanks so much.
Thank you.
Thank you.